Hi, so recently I bought this turbomolecular pump, but in order to use it you need some special controller which I didn't have, so I figured to simply use one of these Chinese BLDC motor controllers. However, this means I have to figure out the pinout myself by taking the pump apart. Turns out you shouldn't unscrew everything you see. I accidentally unscrewed 6 hand-trimmed balancing screws in the rotor assembly that are essential for balancing the rotor. Yikes. This mistake caused the pump to run extremely loudly with a large amount of noticeable vibrations at only half speed. So I decided to redo the balancing by measuring the imbalance myself, similar to how it's done at the factory. I ended up using an Arduino Duo with a high precision accelerometer, the EXT250 TMP, and feed the whole signal into the same Arduino to determine its imbalance and angle. The accelerometer is basically just taped onto the bearing block, as you can see. The accelerometer is pretty expensive with around 50 euros, but the precision is necessary for the measurement. After writing some simple Arduino and Python code with the help of ChatGPT, I treated the data as complex values and unwrapped it around the unit circle at the rotor frequency. That way I can see the imbalance and its angle. The angles between the physically possible Hall states are interpolated, and the final imbalance and its angle are calculated and shown here as this red vector. The measurement itself is based on 4096 data points collected in about half a second. As you can see in the screenshot, I started out with an imbalance of roughly 1750 at around 37 degrees. The units here are raw ADC bits. For these measurements I spun the pump up in free air to around 80 revolutions per second, which is an easily achievable speed at atmospheric pressure and far away from any resonances. Then I took a look at the impedance diagram. After noting the imbalance and its angle, I stopped the pump, unscrewed the screw with too much mass according to the diagram using this monstrosity, and removed some material. After screwing the balancing weight back in, I spun the pump up again, checked the diagram and adjusted things accordingly to reduce the length of the vector. This whole process took about an hour, and if you're unlucky, the screw might fall into the pump housing. After some work I was able to reduce the imbalance vector to a length of about 30, which is roughly a reduction in vibration by a factor of 60. Pretty impressive. The pump is no longer audible at half speed. The vacuum performance is still pretty bad because of skin oil, water and some loose vacuum fittings. I hope this video gives you some ideas on how to approach it without having access to high precision balancing equipment. Thanks for watching.